let's take a look at this first one, density bellwork number 1. Mercury metal is poured into a graduated cylinder and has a volume, that catches my attention, 22.5. The mercury has a mass of 306.0 grams. From this information, calculate the density, okay? So that's what we don't know is the density. So my density equation is D equals M over V. So if I plug in my mass and my density, I got 306.0 or 22.5. How many sig figs, Danielle, does 306.0 have? 4 sig figs. Sarah, what about 22.5?
3.
So then, Laura, how many do I have to keep exactly in my final answer?
3.
Yep, weakest link. No more, no less. Okay, no more, no less. Now, if you plug this into your calculator, it'll tell you 13.6. And how many are you allowed to keep there? 13.6. So it actually works out just fine and dandy. No rounding necessary. What are the units on this guy? Grams per, huh? Grams and milliliters. So is one over the other or what? Grams per milliliter. There we go. Love it. Looks pretty good. So that bellwork will look like that. Remember, on your quiz, you will need to solve for density like this. But you also need to be able to solve for mass and for volume. So you got to be able to rearrange that equation and get mass and volume by themselves as well. So people want to talk about number 3 on this density bellwork number 1. It's good practice for your quiz coming up next week. So in this particular problem, I'm asked about the mass, okay? So I must have been given volume and density at some point in some fashion. I'm given my volume, but it's not directly. I have to go ahead and find out the volume of that cube. So as we know, volume equals length times width times height. In this case, that'd be 5.8 times 5.8 times 5.8. Your calculator will in fact tell you that that is what? Was it 195.11?
Yeah.
0.12?
1.12.
Oh, I see. Let's go to 195.11. Good enough. Now, how many sig figs am I allowed to keep? 3. And when I say allowed, what I should really say is how many do I have to have exactly? No more, no less. It would be 3. So on my answer key, you'll notice that it says 195.11, but I have a little arrow that says 3 sig figs. I'm only allowed to use the first 3 sig figs. In this case, that would be 195 for our volume in this particular case. Now, what was that?
Will we always only have to use sig figs?
We'll be using sig figs the rest of this unit for our calculations, and then we don't use them so much the rest of the year.
Okay,
but
so for every equation, we just have to...
You have to keep your sig figs in mind. Yes, sir?
Why do we do the sig figs before we multiply the next column? Wouldn't it be more accurate to use it in its decimal form?
That is a great debate. That's a great debate. I actually was talking with the other chemistry teachers about that. Like, shouldn't we just keep that 0.11 and then take care of sig figs at the very end? I'm teaching to you guys for this way, because this is debated somewhat, because I don't want you to forget that you're only allowed to keep those 3. And I worry that if you keep that 0.11, that you'll think there's 5 sig figs there as you get further down the line in the problem. Great question, though. Very fair question. Anywho, if I am looking for the mass, we know that mass, I'll do the second step in green, mass is going to be equal to the density times the volume. In our case, that's going to be 0.917 times 915. We multiply those together, we get 178.815. How many sig figs do I have to keep? 3. So I cut it off after the first 8, and I should be left with an answer of 179. That second 8 tells the first 8 to round up, and the units on that should be grams. And that's my final answer right there. Great. Alrighty, so we're going to talk about problem number 4 on density bellwork number 1. So we have gasoline is a liquid that will float on water. Okay? 450 grams, alright, so that already catches my attention, of gasoline is spilled into a puddle of water. If the density of gasoline is 0.665, what volume of gasoline is spilled? Okay, so I'm looking for volume. And if I remember, density equals mass over volume. So I want to get volume by itself. So what can I do to both sides to get volume closer to itself, closer to being by itself?
Multiply by V.
Yep, multiply both sides by volume. So the volumes cancel out over here. And now I at least have volume in the numerator. So what can I do to both sides now to get volume by itself?
Divide by V.
That's right. So I'll divide both sides by density. And so the densities will cancel out over on this side. So now I'm left with volume equals mass over density. Okay. Well, in this particular case, that would be my 450 grams divided by 0.66 fiber. Your calculator will tell you that that is 676.69. How many sig figs am I allowed to keep? Where'd you get 2 from, Alexa? 450 has 2 sig figs. What about the 0.665? Yep. So our weakest link is the 2 sig figs, so I'm only allowed to keep 2. So I find the second sig fig, this is the 7 here. I'm going to round after this. Now I'm not chopping, I'm not just going to call my answer 68. Okay? So what does that 6 tell that 7 round to? An 8, but I need to keep the placeholder, so my final answer will actually be 680. If I make it just 68, the size of my volume calculation here is plummeting. We don't want the size to really change. We just want to change the number of sig figs. Okay? So there's that. And then what are the units on this? Milliliters, because this is talking about a liquid. Wonderful. Boom. Okay, so there's a little practice there for you. Yes. You're listening at home. We are all good to go because we're going to do a test tube challenge. So home folks are all good to go. I will